Ahoy from BA! This is a Rorschach Ocean Update from the 17th of February 2026, a summary of what's going down in the 70% surface of the Earth covered in salt water. We start this week with geopolitics unfolding on the high seas. On Sunday the 15th, the United States Department of Defense confirmed that U.S. forces boarded the oil tanker Veronica III in the Indian Ocean. ABC News reported that the vessel departed Venezuela in early January, carrying nearly 2 million barrels of crude and fuel oil. Pentagon officials described the boarding as a right-of-visit operation conducted under international maritime law and released video footage showing personnel securing the ship. U.S. authorities stated that the operation was part of ongoing sanctions enforcement related to Venezuelan energy exports, underscoring how maritime shipping lanes remain central to global geopolitical tensions. That enforcement takes place within a broader framework of ocean governance. On Friday the 14th, Ocean Rising reported that 16 countries participating in the Ocean Pioneers Initiative, a coalition advancing high-ambition ocean governance, are coordinating ahead of upcoming international negotiations. According to the publication, participating governments are working to align biodiversity protections with the recently adopted agreement covering marine areas beyond national jurisdiction. Representatives involved in the Ocean Pioneers Initiative stated that stronger coordination between conservation bodies, fisheries authorities, and monitoring institutions will be essential to ensure that new legal commitments translate into measurable protections across vast areas of the high seas. While governments debate frameworks, scientists are tracking physical changes in the ocean itself. Oceanographic magazine reported that researchers at the University of Colorado Boulder identified a freshwater surge in the southern Indian Ocean that could influence large-scale ocean circulation. The scientists explained that increased surface freshwater reduces salinity and strengthens stratification, limiting vertical mixing between ocean layers that normally redistribute heat and nutrients. The research team stated that sustained changes in mixing patterns could influence regional climate regulation and marine ecosystem productivity if trends continue. Regional seas are showing signs of atmospheric disruption. Scientists from the Leibniz Institute for Baltic Sea Research reported that persistent easterly winds pushed water out of the Baltic toward the North Sea. Sweden's landsort Norra Gauge fell to its lowest recorded level since systematic measurements began in 1886. Researchers emphasized that prolonged low water conditions can affect coastal navigation, marine habitats, and basin circulation. The institute stated that sustained wind systems are capable of rapidly reshaping semi-enclosed marine environments over relatively short time frames. Meanwhile, climate variability continues to shape ocean conditions and global weather systems. On Thursday, the 13th, the National Oceanic and Atmospheric Administration's NOAA's Climate Prediction Center reported in its latest advisory that La Niña conditions remain present in the tropical Pacific, with a transition toward neutral conditions expected in the coming months. During La Niña, cooler water strengthened trade winds and shift tropical rainfall patterns westward. NOAA scientists stated that this phase typically brings wetter conditions to parts of Southeast Asia and northern Australia, increases the likelihood of drought in portions of the southern United States and South America, and can contribute to a more active Atlantic hurricane season. It can also shift storm tracks across the North Pacific and modify coastal upwelling patterns that support fisheries. New research is also reshaping how scientists understand Antarctic sea ice variability. In a study in Communications, Earth and Environment, lead author Wei-Han Ma of the Institute of Atmospheric Physics at the Chinese Academy of Sciences and colleagues identified what they describe as a tripole-like pattern in Antarctic sea ice. A tripole refers to a three-region structure of contrasting sea ice anomalies, rather than the traditional two-region dipole pattern long associated with Antarctic variability. The researchers found that this third anomaly center shifts seasonally between winter and spring. According to Ma and co-authors, the pattern is linked to atmospheric wave trains originating from the Indian Ocean and maritime continent, suggesting that remote tropical forcing plays a stronger role in shaping Antarctic sea ice than previously thought. Next up, active conservation efforts are unfolding in the Southern Ocean. On Monday the 16th, Sea Shepherd Global announced the launch of its 2026 Operation Antarctica Defense campaign following the departure of its vessel Alancai from Ushuaia, Argentina earlier this month. Sea Shepherd reported that its crew documented industrial krill trawlers operating near Coronation Island in Antarctic feeding grounds where humpback whales and other marine wildlife were present. Krill forms the foundation of the Antarctic marine food web, and the organization stated that large-scale harvesting can reduce food availability for whales, seals, penguins, and seabirds. The campaign will focus on independent monitoring and public reporting on what Sea Shepherd describes as increasing fishing pressure in the Southern Ocean. In other news, ecological responses to warming seas are becoming increasingly visible. On Tuesday the 11th, Oceanographic reported on long-term monitoring conducted by marine biologists studying loggerhead turtles in Cabo Verde. Researchers observed earlier nesting patterns linked to rising sea surface temperatures. The same team documented that female loggerheads are breeding approximately half as often as in previous decades. The scientists attributed the shift to changes in prey availability and broader productivity patterns in surrounding waters, noting that altered ocean conditions may be influencing reproductive timing and frequency across the population. Coral science is revealing unexpected evolutionary patterns. On Wednesday the 12th, Oceanographic reported that marine biologists studying hexacorals across the Atlantic and Indo-Pacific identified genetic connectivity between populations separated by vast ocean distances. The researchers concluded that coral evolution reflects more complex patterns of historical gene flow than previously assumed. According to the study authors, ocean circulation patterns may have facilitated broader dispersal pathways across major basins, reshaping understanding of coral lineage development and long-term connectivity between reef systems. Meanwhile, coastal communities are responding directly to reef stress. On Thursday the 13th, Ocean Rising summarized conservation initiatives in Mauritius that combine coral propagation, reef monitoring, and community engagement programs. Project leaders stated that restoration efforts aim to strengthen local fisheries, support tourism economies, and stabilize shorelines vulnerable to erosion. Organizers emphasized that ecological resilience depends not only on scientific intervention, but also on sustained local participation and supportive national policy frameworks. On another note, on Friday the 14th, Oceanographic magazine reported that marine policy analysts are warning that newly adopted biodiversity agreements will require substantial enforcement infrastructure to become effective. According to the publication, experts involved in governance discussions emphasized that monitoring systems, compliance verification, and funding mechanisms remain central challenges. While diplomatic progress has advanced rapidly, analysts stated that translating legal commitments into operational oversight across vast ocean areas will require sustained political coordination and technical capacity. And to finish off this week's update, an opinion-style feature on ocean energy. On Saturday the 15th, the New York Times published a science section feature by Delgar Erdenasana titled "These Unsinkable Tubes Could Help Harvest Energy from the Ocean." In the article, Erdenasana examines a new wave energy design built around aluminum tubes engineered to trap air bubbles and remain buoyant even in harsh sea states. The piece outlines how the system could convert wave motion into electricity, while addressing engineering challenges such as corrosion, durability, and maintenance in high-energy marine environments. The article also considers the broader question of how far societies should go in expanding renewable infrastructure at sea and whether wave energy can meaningfully contribute to decarbonizing global power systems. To read the full piece, check out the link in the show notes. And that's it for this week. Thank you for joining us. For those who may want to find out if we get any of these updates going again, go to rorschach.com/updates. It's also in the show notes. There you can give us your email address and we will let you know if anything changes. And of course, you can always just send us an email to info@rorschach.com and let us know to keep you informed. But most of all, thanks for the outpouring of support. See you next week.